Hi guys, welcome to the continuation of topic number 7. Okay, we've already looked at limiting factor analysis. Now we need to move on to linear programming. And the way that we're going to handle linear programming is by completing an introduction, which is this recording. And then there are several apply your knowledges. Okay, these will be handled in separate recordings, and they will then also address your introduction, which is now, we've got some calculations to look at. We've then got to move on to shadow and slack pricing as well. Okay, so quite a few recordings with linear programming, this being the first. So here we've got an introduction to linear programming, and linear programming just builds on the understanding of constraints as we looked at in your limiting factor analysis. So in your limiting factor analysis, what we said was we had our chocolate bars. Just going to copy this across. Okay, if we just take that down. No, it didn't work. Sorry about that. So we'll start again. We've got our chocolate bars and we've got our nice little sachets and we've got our chocolate eggs. Not to forget 0 calories and a weight loss assistant. If any of you ever do invent this, by the way, please let me know. All right, and obviously within our products, we've got our milk, we've got our chocolate beans, and we've got an element of labour as well. So they're the resources that we're going to need. And what we said was that if we've got a constraint, so in the previous topic where we looked at limiting factor analysis, we had one constraint, didn't we? And that means that we can't produce as many as we'd like to, and therefore it limits the profit or contribution we can earn. So we undertake limiting factor analysis to identify exactly how many of each product we should actually make to make best use of our limiting factor and therefore generate the most profit under the constraints that we've got. Linear programming aims to do exactly the same thing, in that linear programming aims to give you, as an organisation, a plan for your optimum product mix. So it will tell you how many to make of each product, just as we did with linear programming, and therefore how to maximise your profit. However, the difference is that we now have more than one constraint. So we've got more than one limiting factor. And if we've got more than one limiting factor, then we can't use limiting factor analysis. It simply won't work. And therefore, we use something called linear programming. And linear programming is a method that we're going to use to give us our optimal product mix and to tell us how much profit we could earn, given the fact that we've got more than one constraint. So in your exam, you're going to have at least 2, and I wouldn't say any more than 3. Okay? Before we get into just having a look at the approach for linear programming, you will see the questions that we do in these tutorials, they are quite long. We're going to have a 6-step approach, effectively, that we use, which is fantastic. But there's a little bit more work to these 6 steps than there was in your limiting factor 5 steps. Therefore, it's highly unlikely that you would have to complete all 6 steps in your objective test. It's not going to happen because it's worth far more than 2 marks. If you were to complete this, a full linear programming question by completing all of these 6 steps, you're probably looking at around 14 marks. Okay, therefore, you won't be given that to do. However, they could ask you to do any element of the 6 steps, and equally, that they may have done steps 1, 2, and 3, and you need to do 4, or just depending on what it is that they're trying to do. So, as with most things that you're learning, you need to make sure that you understand the big picture and able to go in and deal with snippets of that. So, we will obviously see exam-style questions in masterclasses, and there'll be more questions available to you in your Kaplan kit, in your mocks, and in your additional questions. But for these tutorial purposes, I will be doing full questions to make the most of our time, and so that you can see the whole picture of linear programming. Okay, so just to make it clear, I don't want you thinking that you're going to have to do all of this for 2 marks, because you wouldn't. Okay, so before we move on to a question and look at the numbers, and it really is with linear programming, as with most of the things, it's all about practice, 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 practice. I just want to give you an overview of the approach that we're going to use. The approach that we're going to use for linear programming is this. And you will use this approach because even though you won't have to do all of these steps, you'll need to figure out which of these steps have been done for you in order that you can then move on to the next one in your objective test. Okay? So, what have I drawn? I've drawn a pie. Okay? Now then, the way that I deal with linear programming is I remember DOF pies. Okay, DOF pies has worked for me for years. It worked for me during my exam, and it's worked for all of my students. So I ask you all now to embrace DOF pies. I will also tell you a story about how DOF pies was actually born. When I was sitting my exams several years ago, I obviously had to undertake linear programming, and if I'm honest, I found it a little bit challenging because I used to get confused on which part of the process I was undertaking. And I thought, this is ridiculous, I just need to get my head around it. And so I listed out all of the steps involved, and I was always trying to find different acronyms for processes in my exams. I had so many, but I sat and looked at this, and slowly these letters started to forge their way out as I was trying to make words, okay? And I thought, it's still not coming to life. And then when I was doing a study session at work, my director of finance came in the room and asked me a question about some work I'd been doing. And then it all fitted into place. My director of finance at the time where I was working was a pretty huge guy, okay? Now, I'm not a sizist, okay? I have body image issues the same as everybody else, and I have weight to lose, the same as lots of other people, so I'm not concerned about that. However, he was a big fella, and we did used to say, we weren't horrible about him, but we used to say, blooming heck, he's at all the pies, okay? And so became my director of finance, who ate all the pies, and that just matched hand in hand with linear programming, because that gave me DOF pies. Okay, so that's where DOF pies comes from. So you can always imagine now a nice fat director of finance, which is all good, but DOF pies will absolutely get us through our linear programming. What does it mean? Well, step 1 is your D, which is to define the variables. And what will happen is, if you imagine that let's say we've only got 2 products in our organisation. Let's say we've got our chocolate bar and our chocolate egg. And obviously, when we're undertaking linear programming, we need to know how many we need to make of our chocolate bars and how many we need to make of our eggs. Well, instead of calling them bars and eggs, we will call them X and Y. In your exam, you will only have 2 products. You won't have more than 2 products. And so you are going to state that X will be the number of, let's say, chocolate bars, and Y will be the number of chocolate eggs. Now the chances are they are going to call them X and Y, and if they don't, remember you're not doing a written exam, but for ease I would always change them to X and Y, because you will always handle X and Y in every single question that you do, and it makes every single question feel the same if you do that, I promise you. So you define the variables, which is telling your examiner that you're using a shorthand and we're renaming the products. You don't need to tell your examiner anything, okay, because you're not doing a written exam. However, in your calculations, I would still define the variables and I would still make them X and Y. You then need to define and formulate the objective function. So this is your O. So we've defined the variables. Now we formulate the objective function. And the objective function is simply saying, what am I trying to achieve? And what you're trying to achieve is maximum contribution or profit. So let's say my contribution per unit for our chocolate bar is $10 and my contribution per unit for our eggs are $8. For example, if we were defining the objective, we would say 10x add 8y equals maximum profit or maximum contribution. We need to know the number of X and we need to know the number of Y, and we will continue on and create those numbers. But we know that in order to maximise our contribution, we will take 10 multiplied by X and add it to 8 multiplied by Y. If we were dealing with profit, then obviously we'd look at the profit per unit and we could just substitute in here for our profit per unit. That's absolutely fine. Okay, and in your objective test, you could be asked, what is the objective? Okay, it could ask you to formulate that, and you need to simply pick it from a multiple choice scenario. So you'd have to do some workings for your contribution per unit, and you'd pick 10x plus 8y. Okay, so that could be worth 2 marks. So that's step 2. Step 3 then is to formulate the constraints. So this is about saying, well, what is it that's stopping us from achieving maximum demand levels or maximum production levels? And what it will tell you, like we did in limiting factor analysis, it will give you information about how much resource each of your units take. So it might say, do you know what? Your chocolate bar uses 1 kilogram of milk, and not kilograms, litre of milk, and your egg uses half a litre of milk. And for chocolate, it uses 2 kilograms and your egg takes 1 kilogram. Let's say that they were your limiting factors. It would then say that you'd have a maximum milk available of, let's say, 10,000 litres and maximum chocolate available of 5,000 kilograms. In order to formulate the constraints, all you are going to be doing is writing these down in a sum format. So you would say that you need 1 litre of milk in every X and half a litre of milk in every Y, but you cannot exceed 10,000 litres. So the answer to that equation has to be equal to or less than 10,000 litres. And for your chocolate, you need 2 in every X, 1 in every Y, but you cannot exceed 5,000. So all you have done is formulated the constraints. You've taken the words and you've put it into a sum. And you would do that for all of your constraints. What we also need to put on here is any non-negativity and also minimum and maximum demands. We'll see that when we come to a question. Okay, so define the variables, formulate your objective, formulate the constraints. We've completed D, O, F. So that's your DOF. You then need to come on to your pies. You need to identify points to plot. So what we're going to do is we're going to take these constraints that we formulated, do a little bit more work with them, and it will give us some coordinates which will enable us to draw a graph. Now on the day, you're not going to have to draw a graph, but you may have to calculate coordinates and place the relevant lines on your graph, or you may have to pick out certain points on the graph. They could show you graphs that you have to interpret. So we need to make sure that you're happy with the graph and pulling it all together so that you can then pick out any aspect that they ask you. So we'll have a look at how to do that. So that's your P. We then need to create something called an ISO contribution line, and this basically shows us the answer. Okay, and it shows us the answer on our graph. Okay, so again, we'll see that in action. And then finally, we need to do simultaneous proof of coordinates. We need to be doing simultaneous equations. Some of you may never have done them before. Some of you, this may be, you know, a piece of cake. So we'll take it as though nobody knows anything, and that way we'll get everybody covered. And what this is going to do is it's going to prove the answer. Okay, so it's going to prove your ISO contribution line is correct. So we define the variables, we state the objective function, we formulate the constraints, we identify the points to plot, we create an ISO contribution line, and then we do a simultaneous equation. And that, ladies and gentlemen, is DOF pies. Okay, that's how it works. That's how we piece it all together. In the exam, as I say, you may find yourself 3 steps in or 4 steps in, which is fine. You need to be able to pick them all off. Okay, so what we'll do is we'll have a look at Apply Your Knowledge 1, which will take us through a full example, and it will take us through every single one of these steps. But we'll do that under a separate recording. So thank you for listening in, and I'll see you on the other side for Apply Your Knowledge 1.